Hello, lazy chemists. Welcome to today's lecture, which is going to be on functional groups in organic chemistry. Okay, so first we're going to go ahead and define what a functional group is, and it's going to be a grouping of atoms in a molecule that have similar properties regardless of the other atoms or elements within the molecule. All right. So these are going to be groups that when they're in a long carbon chain are going to go ahead and interact all the same way. And because they all interact all the same way, it means that we can go ahead and group them together as a whole class of molecules. The first set of functional groups is going to be our main carbon functional groups. And in general, when we are talking about carbon functional groups, we like to assume a couple of things about them. First is if they are single bonded carbons, those are going to be our main body chain. And our main body chain in general, we're going to go ahead and say that those are anes. All of those are going to end with anes. So for instance, this first molecule has a single bond and it has two carbons with it. So we're going to end up calling that ethane. Okay. The next type is going to be an ene group, and this is going to be any time that we have a double bond. Those molecules, we're going to go ahead and call them enes, or we will leave them with a last suffix of ene, E-N-E. And so this is an example of ethene, okay, where the E is going to be our prefix, and then it's going to be ene because we have a double bond there. Okay. The last one is a triple bonded pair, and a triple bonded pair is going to go ahead and end with Y-N-E, and this is going to be an ine group. So whenever we have a long carbon chain, we're always going to say that it's an ine if it has a triple bond somewhere in the main body chain there. Okay. So again, these are our main body groups. These are the ones that are straight. They're going to be anes, enes, and ines. Whenever you make a circle, those are also going to have the same kind of prefixes. Often you will see that most of the carbon rings are going to be double bonded in some form. So that makes it so that it's going to end up being benzene rings. And then again, we can end up having other things attached to those benzene rings. And that's going to end up changing the properties of it right then and there as well. Okay. So for instance, this has what's known as a methyl group on top. So that's going to be methyl benzene. This one here has a chlorine on top. This will be a chlorobenzene. Okay. So it still has the same main body type of carbon ring. But we end up calling it benzene because that's the type of that's the name of a ring carbon structure like this where it has double bonds. Notice that it has double bonds, so it has an E-N-E. We're also going to have sidechain carbons, and we're going to learn the name for these as well. In general, sidechain carbons are also going to be a functional group. This is known as a methyl functional group. When we have one carbon grouping all by itself, it's going to be methyl. If we had two, it's going to be ethyl. 3 is propyl. And then we're going to learn more of those names when we get to the naming. Right now, you just need to be able to recognize that, hey, when we have an offshoot that's like this, it's talking about a carbon group that's coming off of there. Okay. And this is also why we end up getting these names like methamphetamines. And that's because we have these methyl groups coming off of an amine group that's, right here. All right. The next type of functional groups is going to be oxygen. We're going to devote a whole bunch of our memorization powers to going ahead and identifying these oxygen ones, because oxygen being so ubiquitous and it also having very different properties from one another is going to be one of the reasons that the oxygen functional groups are going to be really important. And where they are in terms of the molecule is going to depend on how they are going to react in that molecule. So the first is going to be our alcohol groups, and all of our alcohol groups are going to be some carbon structures that end up having an OH group at the end of it. So no matter what, if it ends up having an OH group, it's going to essentially be an alcohol. Here, this one has an OH on the second carbon, which is why it's propan-2-ol. Okay. Here we have another example. We have an OH group on the second carbon. There's 4 of them. This one's butan-2-ol. Okay. All of these end up being alcohols because of this OH group. Next we have esters and ethers. Okay, and esters and ethers are going to be kind of similar in that we're going to have our main body group here. So whenever you see this R in any sort of writings anywhere, you can assume that there's some carbons that are going off this way. The same also goes for this R here. And ester group is going to be where we have a double bonded oxygen to a carbon, which is also connected to another oxygen, which is then connected to a whole bunch of other parts of the carbon chain. And ether here is going to be where we just have an oxygen right in the middle of a carbon chain. All right. Next, we're going to go ahead and have aldehydes and ketones. And aldehyde is going to be where we have a double bonded oxygen to a carbon. And that carbon is then a terminal carbon that has a hydrogen on it. A ketone is going to be where we have the oxygen is double bonded to a carbon, and that carbon is then double bonded to another part of the carbon chain. Our last functional group is going to be carboxylic acids, and this is where we have our main group carbon. It's connected to a double bonded oxygen, and then it's connected to an OH here, and this is the carboxylic acid. And this carboxylic acid, especially when we're talking about acids and how they lose a hydrogen, this is going to be a hydrogen that is lost. One thing that should be note is that this is something that has a resonance structure as well. All carboxylic acids do. And this double bond is actually shared in between both of these oxygens, and the same goes for the hydrogen itself. It kind of fits right in the middle in there. It's kind of cradled right in there for the carboxylic acid. So just take note of that this one does have a resonance structure attached to it. That's going to close us out for the oxygen ones. The last type of one is going to be sort of like our odds and ends groups. These are ones that you end up seeing less often, but they're still going to play a fairly important role, especially when we start talking about like the different types of reactions that you could have. The first is haloalkanes, and these are essentially haloalkanes are essentially just all structures that we end up having some sort of halogen attached to it. And the halogen, again, is going to be that group 17 on your periodic table, the fluorine, chlorine, bromine, iodine, and all of these are going to be called haloalkanes because they're all going to kind of have their own similar bonding structure and how they react and everything. Okay, so here, bromine, chlorine, no matter what, we're going to end up calling it a haloalkane if it's one of those that fits within that group right there. Okay, next we're going to go ahead and have amines and amides, and these are going to be our nitrogen compounds. Okay, and an amine group is going to be where you have the nitrogen as a terminator in there. Okay, so notice that the nitrogen, it wants 3 bonds, it has 3 bonds, it's connected to the main chain through that R, and then it has these 2 hydrogens here. That's an amine group, whereas an amide group is going to be where we have a carbonyl group is bonded to that nitrogen atom right here. So this here is our main chain, then it comes here and it continues on. So this is a nitrogen in the middle is going to be the amide group, whereas an amine group is going to be where the nitrogen terminates our carbon chain. The last is going to be a nitrile group. So this is going to be where the nitrogen is triple bonded. Okay, this one is usually a fairly unstable molecule right here, just because of torsion and geometry. And the last is going to be a thiol group, and this is where we have a sulfur attached to a hydrogen terminating our different group there. Okay, so these are the main groups that we need to be able to recognize and see and be able to draw them out if need be. This will go ahead and close us out for this particular section right here. And those are all the functional groups that we have for organic chemistry in this year.